Hello everybody, welcome to the webinar discussing the use of the OpenPHACTS API. Today's webinar will be presented by Paul Groth from VU University Amsterdam. If you can ask any questions regarding the API or OpenPHACTS in general, either during the webinar or afterwards using the question module in the GoToMeeting software, then Paul and the other panelists will do their best to answer those questions at the end. Over to you, Paul.
Hi everybody, I'm really excited to talk to you today about the development aspects of OpenPHACTS, and in particular using the OpenPHACTS Discovery Platform Application Programming Interface. So I'm going to do a very brief background bit on OpenPHACTS, and then we'll dive right into the application programming interface and kind of just try to walk you through what's available there for you to use. I'm going to try to leave about 10 minutes to 15 minutes for questions, and please ask questions in line during the talk. So briefly, what is OpenPHACTS about? OpenPHACTS is about integrating public drug discovery data. So you know that there is tons of different information that we need in order to do drug discovery, from information about chemicals to information about proteins or pathways, and a lot of that information is available in public databases that are not integrated or that take some effort into integrating them. And so what OpenPHACTS does is does the integration for you and provides an open, easy-to-use application programming interface to access that data. The OpenPHACTS Discovery Platform is that product that we provide, and it's created by a consortium. This is a large consortium that's been running now for 2 years. The project consists of major pharmaceutical companies along with leaders in bioinformation technology and in semantic web and linked data technologies. One of the things that we're really excited about at OpenPHACTS is the number of people who've been interested in this semantic integration platform and who are interested in using it. So this is our OpenPHACTS community ecosystem, and these are all the partners, but also what we call associated partners. These are people who have signed up to be part of and are using OpenPHACTS, and we encourage you to, if you're using OpenPHACTS or interested in using OpenPHACTS more, become an associated partner, and you can contact us, and it's a simple process, and you can get up-to-date information about where we're going on with OpenPHACTS, and also some early insight into what we're doing there. So that's the project, to create this data integration infrastructure for drug discovery and to make it easy to access all this data in an integrated fashion. So what kind of data do we have available in the platform and that you'll be able to use through our application programming interface? So currently we have a lot of chemistry data, so information from the Chembl database, as well as information provided by the ChemSpire web service, as well as ACD Labs calculated chemical properties. We also have information about drugs from Drug Bank, and information about proteins from UniProt, and as well as genes from GOA and GOA. So we have this set of data. Currently, it's if we talk in kind of semantic web terminology, it's something like 1.2 billion triples. But we're growing that number of data sources and the amount of data quite quickly. You can see kind of the coverage currently that we have. And what's nice is as we grow this data, as we add new additional data sources, you don't need to change your applications. So what are some of the benefits from using OpenPHACTS, the platform itself? So this is a long list of all the available benefits that you get by using this platform. I won't go through every one of them, but I'll try to highlight a couple that I think are most important to you as developers. One is this access to a wide range of interconnected data. So we not only give you access to compound information or information about proteins or information about pathways, we interconnect that for you, and we provide you this cohesive data sets or a cohesive access. We really deal with the complications of chemistry that you find in this domain. We also host this in the cloud, and I think that's really important for what we provide. So you don't have to worry about managing all this data, taking care of it, making sure the uptime is there. We do that. It's professionally hosted on a high-performance set of machines in the cloud here in Amsterdam. The API is developer-friendly, and hopefully you'll see that in a second as we walk through this. And again, we provide seamless data upgrades. And so there's a lot of these benefits, and I encourage you to investigate these yourself and see what you think. So that's a brief bit about the project itself. Now I want to really dive right into the developer part. How do you access this integrated set of data, and what can you do with that? So we provide a simple RESTful API to access this data. I'm going to talk about how you can go about signing up, and I'll show you a bit of that. And then what we're going to do is kind of build the hello world of drug discovery applications. So what we'll show you is how to go from a particular drug to find more information about it, also find targets related to it, and then putting that together in a really simple way. And finally, I'll tell you a bit about where we're going. So a simple RESTful API. So yeah, if you go to dev.openphacts.org, what you'll find is the get my API keys. If you go click on that, you can go in and just go ahead and register. So username, password, and go ahead and sign up. Next slide. Once you've signed up, what you'll do is you'll get an application ID. So this is the this identifies you as an application as a whole, and each application can have multiple keys. And you'll need these to identify yourself when going and accessing the API. You can create multiple applications there. Next slide. Next slide. So once you've signed up, what we can do is go ahead and start using the API. So what we're going to do is try to build this hello world of drug discovery applications. So this is going from a particular compound, in this case sorafenib, and you see the chemical structure right there and its SMILES code. And this is a liver cancer drug. And we're going to try to find the targets for sorafenib using OpenPHACTS API. Next slide. So the key part of one of the first starting points to OpenPHACTS is the entry points set up APIs. So this is how we go from information you might have, things like SMILES or text strings, into the OpenPHACTS requirements for its API. So next slide. So the API itself is what we call URL-centric. So we have URLs for every kind of concept or identifier in the various data sets we have. And so what we need to do is be able to get these URLs in order to subsequently call new other OpenPHACTS APIs. Next slide. So why do we do this? First, it ensures precise identification. So we know what we're exactly talking about. It also allows for dereferenceability. This means that a lot of times what we can do is we can just take that URL, put it into your browser, and get some more information about this. One of the important things to note here is that we support URLs from many different domains or many different data sets. So here, for example, we can support a URL that identifies sorafenib from ChemSpider or one that identifies it from concept. But what happens if we don't have a URL? Next slide. So we provide a set of entry point APIs. So ones that go from things like free text, so this is the search/free text call, and others that go from chemical structures. So you can do an exact chemical structure search. You can come in with an INCHI or SMILES if you're familiar with those, and get a URL that you can use in subsequent API calls. You can also do similarity search and different types of chemical similarity search. Next slide. So if you actually go to dev.openphacts.org/docs and click on the documentation, and you can scroll down, and if you click on map free text to concept URL, you'll actually see this field. And what you can do is then type in your app ID and app key, and if you're logged in on dev.openphacts.org, you can actually just go ahead and select those from you. They'll already be pre-filled for you. And then what you can do is just put in sorafenib and click next slide. And what you'll get back is this URL. Or this is the URL that gets constructed when you can do it. So you can actually just stick this in a browser and go ahead and point those, and you'll get information back. Next slide. So in this case, you get a bunch of JSON describing what we know about sorafenib in terms of its various information. Right? So this is what we can get back in terms of what are the various URLs that we have for, and synonyms that we have for the term sorafenib. Next slide. So out of that, that response that we get back from our entry point URL from this free text, we can go and find a URL, in this case a concept wiki URL, in this about thing, about field, and we can use that in subsequent calls to the API. Next slide. Again, we can do this for SMILES keys. Here we're putting for, instead of using the term sorafenib, we're doing the SMILES string for sorafenib. And again, we can get a URL for sorafenib. Next slide. So the same kind of response, we get a URL back that we can use in subsequent calls. Next slide. So now let's use that URL to get some information about sorafenib using our compound APIs. Next slide. So we provide two kinds of compound APIs. So we have this compound information, which will kind of give you a summary of the various of the compound, information about its chemical properties, information about, gives you, for example, the image of the compound. We also have compound pharmacology paginated, which will give you essentially mappings from the compound to targets and also information about the assays. So let's go ahead and give you an example of that. So next slide. So we take that URL that we got from searching for either the SMILES string or the term sorafenib, and we go ahead and we paste that into the URI field, and we go ahead and send our request. Next slide. And we get some information back. And this is kind of breaking down what kind of information you get back from the compound information query. And so at the top, you'll see information about the molecular weight, the molecular form. On the bottom, you'll see information about its log p values or whether it has Rule 5 violations, also INCHI keys. And what's interesting about our API is that for all the information that we provide you, we give you an in-dataset field that tells you where the data came from, its provenance. Next slide. You also get information from drug bank about that chemical. So again, this is from drug bank, but now you get information about providing description, information about its toxicity. So here you can see that what we've done is we've integrated all that information from all these three different sources for you in one API call. Next slide. So let's look at compound pharmacology. So again, we go ahead and we put in the URL for sorafenib that we got from our entry point URLs, and we go ahead and hit go. Next slide. And what we get back is we get back essentially a paginated set. So you can specify the number of pages that you want back and how many results you get back on each page size. Next slide. And so what you'll see is in the compound pharmacology paginated is you'll have information about that molecule. Then you'll have information about targets that relate to that molecule. And then that information about the target, so describing the assay, where that target hit that molecule, or where that molecule hit that target. And we now have information about that target itself. Next slide. So again, the information about the assay, where it comes from, the title of the assay, what kind of units is it, what the activity type is, this kind of information. Next slide. So now we have that URL for a target. So we've gone from our compound, we've looked up sorafenib, gotten the compounds, queried compound pharmacology, gotten information that that compound is related to this particular target, and now we can go and inquire about the target itself. So go ahead. So again, a similar kind of API. We have a target information, and we have this target pharmacology paginated. Next slide. So what we can go in is, again, we took the target URL that we got out of the compound pharmacology paginated call, and we're going to put that into the target information call. Next slide. And so now we can get more information about this target information coming from Chembl and Uniprot. So we can get information like the organism that target was part of, keywords, its sequence of the target, also different labels for that. Next slide. So now we can put all this information together. Next slide. So we can do is we can go from a keyword. So we can just actually copy and paste this into a browser, and I would have done that if we had technical difficulties. And what we get back is information that lets us go to provide us a URL that we can use in subsequent calls. Then we can use that URL and call pharmacology for compounds. So we did that. So now we have information about the pharmacology related to sorafenib. And now finally, we can look through that pharmacology, find the mapping to a particular target, and find subsequent information about that target. So what we've done here is go in 3 URLs, gone from a compound to a target. So this is a super simple drug discovery application built in 3 URLs. Next slide. So, hello world. So what we found is that there's a dual specificity protein kinase that's related to sorafenib. And so that's our result from going through these really simple queries that you can do directly using really simple RESTful APIs. Next slide. So what else can you do with the API? Next slide. We provide classification APIs. So this is quite nice. So say you have a KEBI class that you want kind of information about a set of enzymes or a set of compounds instead of just a particular compound. What you can do is use these classification APIs to get information about a wide range of compounds that are categorized, or compounds or targets that are categorized according to different hierarchies. We support multiple types of filtering on activities, so you can sort your pharmacology information using different activity values, and those are all normalized for you as well. And I really encourage you just to get into the API itself, and if you go to dev.openphacts.org/docs, I think the documentation there is fairly straightforward, and essentially you can just issue all these calls yourself and see the results right in the browser. Next slide. So client libraries. Obviously, you can write your own fairly easily client, because all this works through standard web services, and it's really easy to build client libraries to access the API. There are already API libraries for Ruby and JavaScript, as well as Java. Next slide. If you're not wanting to build from a programming language like Ruby or JavaScript, you can also use tools like KNIME and Accelerate, and we have a page, dev.openphacts.org/workflow, that provides you access to nodes that can be used to access our API from these various workflow tools. And we know these are commonly used within, especially Pipeline Pilot, within pharmaceutical organizations. Next slide. Most of our code is available completely as open source. It's all on GitHub, so you can go look at it and also contribute back or find the various libraries I mentioned. That's github.com/openphacts. Next slide. So what you're looking at now is our version 1.2, providing what I've just described. We have a release coming soon, so early this fall, that will provide a number of extra data sets. And this is where you'll see that by adopting the OpenPHACTS API, you don't really have to do, you can really concentrate on building your own application. And you don't have to worry about dealing with, for example, Kemble updating, or you automatically get new data for free. For example, we're adding pathway information. We're doing some really cool things around a new chemistry registration system to do better chemical structure searching. We also have some interesting things about being able to adaptively bring back data for you depending on your scientific use cases. And we're adding more hierarchy and classification support, as well as support for lists of data. And there'll be some bonus data sets coming as well. So I think if you get started with the 1.2 release, you'll be really pleased with the 1.3 release coming up and the added value we give you there. So next slide. So that really ends this kind of quick overview of the OpenPHACTS API. I really encourage you to explore dev.openphacts.org, sign up for your own API keys. You'll also find a support page there, and we're really interested in your feedback, and we have plenty of time for questions. Thanks.
Okay, thank you very much to Paul Groth for walking us through the OpenPHACTS API. So if you have any questions regarding the OpenPHACTS API or the OpenPHACTS project in general, just add those into the question module of the GoToMeeting software. So Paul, we do have some questions already. So an attendee asks, in dataset uses data.kasabi.com in several places. As far as they know, data.kasabi.com has been out of service for some time and the datasets are no longer available. What happens in this case?
So the data sets are available from our data source. So the data is there, and we just use that URL because that's when we acquired the Kemble data sets. In our version 1.3, we'll be updating to use data URLs provided by the EBI itself. So that will go away. But for now, you can still know that that comes from our data sources. And in fact, we have a data source call that a data source API, where essentially you can look up that information about that data source.
Thank you. Another attendee asks, where will the pathways information be pulled from?
Wiki pathways.
Is there any support, or will there be support in the future for linking targets to disease?
Can you say that again, Jack?
Is there currently, or will there be in the future, support for linking targets to disease?
So in the future, we plan to support disease data sets. That's on the pipeline, not for 1.3, but for probably 1.4, which will be later in the fall.
Thank you. Does the API support substrings or substructures when you request a URL for an object?
I'm not sure what they mean. If they're talking about substructures searching on chemical structures, yes, we support that, but I'm not sure. Maybe the person can clarify what they wanted.
Okay, so if Simon could clarify that question, please, and we'll move on to the next question. So, target API entry point uses URI. Is there a list of supported URIs from known sources?
Actually, that's a good point. We should make that. We should put that in our FAQ and make that list of APIs. Essentially, we support, for example, the URLs for all the UniProt URLs, the various Kemble URLs, the drug bank URLs. But we should make that kind of list available. So we'll take a note and make that available.
Another attendee asks, will you support JSON LD?
JSON LD, is that it? We're dependent upon we use the linked data API and its Puella implementation. So if Puella supports JSON LD, we will support JSON LD. The current JSON is kind of designed specifically to be very easy to parse, not necessarily compatible with RDF.
Thank you. Will the inclusion of indication information be added, or linking compounds to disease?
I'll let Lee or Christine answer that.
Yeah, can you hear me?
Yes.
Can you hear me?
Yes.
Okay, sorry. Yeah, so yes, okay. So the roadmap on disease, as Paul outlined for sort of the target connectivity, is towards the end of the year, and that's really so each release forms a sort of a different focus. So the first release was really centered around pharmacology data. This next release starts to bring in pathways and some other data sources connected to sort of protein and compound information as well. The sort of the work, I guess, from the autumn towards the end of the year is really focused on disease and bringing in connectivity both at the compound and the target level. And I think it would be interesting, people. So we're going to look at sources like DisGenNet, ORMIM, some text mining data, this kind of thing. So it'd be very interesting if people, have identified sort of key, interesting resources they think should be connected to Zane. We'd be keen to hear. But we've got, a good steer from the scientific advisory group as part of the project that this is definitely what they want to see as the next phase.
Thank you, Luke. Another attendee asks, is it possible to retrieve Turtle or RDF XML?
Yeah, so Turtle, RDF XML, I think we even support RDF JSON, are all supported. So, yeah.
Also, does the API support Sparkle queries from another attendee?
The API does not support Sparkle queries, and that's for a number of reasons, but currently we only support access through the API.
Okay. So an attendee noticed that you searched for a specific compound name. They were wondering if you had to be that specific.
You don't have to be that specific, but the text search is fairly mostly based around concept. So if you type in something smaller, you will get results back as well. So no, actually you don't have to be that specific. You'll get a list back with possible entries of what you need. So it's kind of like a standard search engine.
Thank you. So could you point attendees towards the documentation of the JSON serialization and eventually documentation of other formats such as RDF?
So the documentation is within within each of the calls. So if you see in each of the calls, what you'll see is a response template that will provide essentially the RDF description in Turtle of what you get back, and the JSON essentially matches that as well. But we'll also we've done some work on improving our documentation really around these response templates, and so it'd be good to see if that is exactly what what they're looking for, and if they want more information, we're happy to provide it as well.
I think the other thing we should add that I guess Jack is probably most involved in is that we're going to be setting up much more of a sort of developer web presence where we can have, Paul mentioned things like FAQ lists and access, and actually some of the questions that come up. Obviously more than one person would want to answer that question, or people would like to come across this information. So that was kind of one of the more recent decisions to sort of set up a really good web documentation forum type resource that we'll be looking at over the next few months.
All right, thank you. Thank you for the answer. The attendee says perhaps mapping of the terms to RDF terms or ontology would be useful to avoid guessing the response format.
So just to respond there, the response format is documented. It's there in all the API information, and so you'll have all the terms there. But yeah, we can add more documentation. We'll take that as a note. Thanks.
So next question, this is the last question on the list so far. Does OpenPHACTS support JSON-P or CORS cross-origin resource sharing for cross-domain queries?
Yes, it does.
Thank you. How easy is it to add another data source to the system?
So if it's a existing kind of concept that we support, so for example, adding a new compound data set or a new target data set, it's pretty easy. It takes about 2 days to do that. If it's a kind of information that we haven't seen before, then that takes a bit longer, because then we have to figure out, well, what kind of API do we want to provide for that? And so there's some overhead there. It also depends upon how good the data set is in terms of its RDF formatting, what kind of RDF we get provided. But in general, between 1 day and a week to get something in and test it and this kind of thing.
I think the other side of that, there's obviously the technical mechanism to get the data in, as Paul's outlined. The other side of that is just kind of rationale. So OpenPHACTS is obviously a data integrator. We're not trying to integrate everything in the entire world for any reason into OpenPHACTS. We're very sort of use case focused, very sort of scientific. What are the challenges that a scientist has in this domain? What do they need to answer? So I think for another data source coming in, there needs to be a good rationale, a good use case for bringing that in, and essentially, we want to know, what's the benefit of bringing this in and why? Who's going to sort of shout about it, and who's it going to enable doing their work? But if we get that, and that's kind of governed by kind of OpenPHACTS' process for which data sources we bring in, etc. But if we get good use cases to bring them in, then I think what's really nice is we have this infrastructure set up that when you put them in, we have the API. The APIs will obviously have different inputs and outputs, but the way you call the API, the infrastructure will all be there, and that you can kind of rely on it. So I think that it's we want to be sort of cautious about connecting too much in, but once we do put something in there, there's a lot of a lot of benefit for it being in there. And the final thing I'll say on this is that kind of we've had a few use cases now where actually people have not wanted to put another data source in. They've just wanted to actually make that other data source work with OpenPHACTS. So they've got a data source in a very specific area, or an API in a very specific sort of different area, and they've essentially done a mashup using OpenPHACTS to provide you some core drug discovery and compound and very sanitized chemistry, very good chemistry representation, and mash that up with some other data, kind of in a sort of federated example, and that's worked really well as well. So I think we're definitely keen to support lots and lots of good diverse sources, but we're not on a kind of just collect all data sources for any reason exercise, and I think it's going to be a balance of those two things as we go. But I'd say that we're definitely keen to hear use cases and examples as to data sources people might want to include.
So another question: are there any?
Also, one thing to say there is.
Carry on.
One thing to say on that is that we also do quite extensive data quality testing in terms of actually having experts in the field look at the data that we're getting back that we've integrated. So that takes some additional time above the integration. It's just making sure that all the data is cleanly integrated in a way that's really useful for the actual end users of the data. Jack?
So another question, are there any special requirements on technology or process for partners that are required before they make an in-kind contribution to OpenPHACTS?
Lee?
Sorry, I was just getting off mute. That's a very interesting question. So and I think the answer is no. So one of the misconceptions from folks who wanted to contribute in kind is that they have to be semantic web experts to get involved, and I think that's very not correct. So for example, Christine, who's on the call, has done a lot of work with one company on modeling and understanding their data, and another pharma company has been involved. They didn't know anything about kind of RDF or anything, and they wanted to understand more, and so they wanted to kind of walk through the process of converting some of their data into RDF in order to understand, really, it's kind of a data modeling exercise, understanding their own data, forgetting about what the format is. So we've had some good work around with partners on understanding data. A lot of other sort of partners have contributed scientific use cases. So I can say that GSK, for example, have provided some fantastic sort of biochemoinformaticians who've done some amazing workflows. So they don't care about the underlying semantics. They've got an API. They know about data. They've mashed it together and shown some real value of OpenPHACTS at that stage. So I think you've got kind of at the the data side, you've got a lot of modeling. At the sort of usage side, you've got kind of these use cases and other things, and I think then you've got other people who are looking at kind of just implementing the system in their organisations and seeing how it could work for them and enable their company, and really, other people have built applications on top. So other people have just taken the API and built a really nice app that does something on top of that. And various people have been involved in KNIME node creation and pipeline pilot component creation. So really, it's if you have an interest in kind of this sort of scientific data area, I think we can definitely find things to collaborate on for sure.
Thank you, Lee. Just a technical question here. Are there any API calls limits?
So currently we have no limits. We have some kind of very protective limits, not for kind of how much you can call, but just to make sure that we're under some of our resource constraints, and that's 1,000 calls per application per second. So, but we tend to try to not put any limits on the number of calls you can do, and in fact we support quite a lot, and if you need higher amounts, please let us know. I think we haven't come to an application that needs to make 1,000 calls in parallel per second for their needs.
Thank you. So we have another question about disease. Where exactly are you planning to extract indication information from? So as far as I know, only DrugBank provides this data in an open form, and this exists as an open text field and will most likely be quite difficult to mine. Are there any other options that might be worth considering?
Lee?
Yeah, I was going to ask Christine if she's on the line, if she wanted to comment on that. So we are looking at some of the genetics databases which associate gene relationships to disease. We're having conversations with Johns Hopkins about OMIM and the representation of OMIM in the system, and those conversations are ongoing. OMIM is not an open database. There's kind of semi-open, and if there's something we can do with those guys, that would be excellent. I mentioned before text mining. There are some pretty good source protocols now for text mining gene disease relationships, and again, one thing that's nice about Paul showed the sort of in-data set type tags. We can associate other sort of metadata with these kind of things that will give you sort of confidence levels and sources and that kind of thing. So that's sort of some of the places where we're trying to go. Christine, are you able to provide any more?
Yeah, there are some of the data sources we already have, let's say SwissProt, and the data sources that will be coming as NextProt. They also do some annotations around diseases, linking diseases to targets. And this is something that we would also try to specify in some API calls, that we want this particular type of information. So some of the sources, the data we already have, will also be able to supplement the disease information by just creating some new API calls around those things that we need.
Thanks, Christine. One of the sources, one of the groups we're working with are the groups behind DisGenNet. So this is DISGENET. And I'm just looking at their statistics now. They have a full kind of RDF, so they amalgamate data from Mass Genome Database, UniProt, Gene Association Database, CTD, and others, and sort of produce this in a sanitized, aligned format. And they've got 100,000 associations between 9,000 genes and 6,000 diseases. So that's one of the sources that we'll be using, and the groups that we're collaborating to bring in this kind of information. But there are more out there, and I think does GenNet, and obviously it's itself an aggregator of all these other sources I mentioned. That will be our first pass, I think, at getting the infrastructure in place for all of this, and then we'll add in more and more resources as we're able to.
Thank you, Lee. Christine. So I think the last question now is, will the OpenPHACTS API be freely available once the OpenPHACTS project, comes to an end next year?
So I can answer that one, So I can answer that by telling you kind of what the plan is. After the project finishes in February 2014, actually the project will now extend until September 2014, the official IMI project. But very soon, if not already, we will be establishing a follow-on successful organization which will own the infrastructure and keep this thing running. And we already have plans in place as to how we're going to do that, where the funding is going to come from, etc. So the answer is that our vision is that this infrastructure is sustained for long term and grows, and many of us will be working very hard to make sure that continues. And obviously, for the folks on the call, your help in either support using the API, building applications that use the API, whether they be academic or non-profit or actually commercial applications, that's fantastic. The other thing is for sort of the academic folks, we're going to enter into shared grants so that we can collaborate and develop various pieces together. And I think the idea is that the OpenPHACTS API will always be freely available. Now, we may end up, obviously we need to think about sustaining, and we might enter into collaborations with folks who want really massive usage, and do some really nice collaborative work there. But the key principle is that we produce. I guess I'll take back to the start of the project. The start of the philosophy as to why the European Union funded this was this kind of infrastructure was sort of available to pharma companies. They built systems like this, but beyond that, it was very hard, particularly for non-profit and academic institutions, to raise money to build kind of sustainable infrastructure that does this kind of work. So the idea that was to plug that gap. So the intention is, yes, to keep this going for many years, and we're actively recruiting participants to really help sustain this going forward, and keep the API accessible to everybody.
Thank you very much. So if there are no more questions, then it just remains to thank Paul Groth, Lee Harlan, Christine Chichester. And if you have any more questions, then feel free to look at the OpenPHACTS API website, dev.openphacts.org, or the OpenPHACTS project website, openphacts.org. All right, thank you to all attendees and presenters.
Thanks, everybody.
Thanks, everyone. Bye.
Yes, bye-bye.